Alrighty, so maybe I can start with introducing myself. So hi everyone, my name is Neha Garg, and I'm a product lead here at Udacity. In my role, I work on deciding what courses we build and why. And last couple of months, I've been working on some of the cloud programs that we launched very recently. So we have launched 2 cloud programs very recently. One is the Cloud Developer Nanodegree program, and the second is the Cloud DevOps Nanodegree program. And Ivan here is one of our instructors for our Cloud Developer Nanodegree programs. And I am very excited to have Ivan join us today as a presenter for the topic, Evolution of Cloud Computing. So a bit more about Ivan. Ivan is a rock solid software engineer. He has an extensive experience across many domains, including cloud computing, blockchain, cloud architecture. Currently, before his current role, he was prior to this working with AWS on their logging and monitoring system, where he builds like large-scale softwares for CloudWatch. And now he focuses more on helping people understand that world better. He's an avid blogger, avid instructor, and we are very excited to have him join today. So with that, Ivan, the floor is all yours.
Thank you very much. Thank you very much for introduction. And let me just share my screen so I can show you the slides for this talk. And do you see the slides?
Yes.
Okay, so hi everyone and welcome to this webinar. It's called Evolution of the Cloud from IaaS to Serverless. And in this webinar, we will talk about the evolution of public clouds and how this evolution changes the way we develop and deploy our software. Okay, do you see this thing, sorry?
Yes.
Okay. So through the evolution of cloud services, cloud providers implemented a number of technologies that allow us to deploy our application in a number of ways. And so what we will do in this webinar, we will look into the history of cloud providers, of public clouds, and we will see what options do we have and had to deploy our applications. So what we'll start with is on-premise deployment, which has nothing to do with the cloud, but this is what we started with as an industry. We then will go to infrastructure as a service, and what it means is that it allows us basically to rent machines from a cloud provider. And then once we cover that, we will go to containers as a service, and this allows us to run our application in multiple containers. And if you're not familiar with this term, we will cover it as well. Then we will talk about what is a platform as a service, and this is, in a nutshell, a way for a provider to manage most of the infrastructure and abstract us away from details such as, and all we need to do in this case is specify what application to deploy. And the last thing that we will cover in this webinar is function as a service, and it is also related to a concept called serverless. And in this webinar, we'll first of all discuss pros and cons of each option because there is no silver bullet, and we will talk about each one of these options. And I need to say you that we won't be able to cover everything in this webinar. We will just cover the basics, but if you want to learn more, then please go to the Udacity Nanodegree that covers those options in more details. So first of all, we will start with on-premise deployment, which was the main option before the rise of cloud providers. And what is on-premise deployment? Well, in on-premise deployment, we own a data center, or a company owns a data center. It may even own the building where the machines are running. The company would have to buy hardware. The company would have to install hardware, configure hardware, connect it, and it would have to run application using its own hardware. And it was, of course, prevalent before the cloud. And it still has its merits, so there's still reasons why we would want to avoid cloud, and we will talk about this in just a couple of minutes. But the main question is why it was changed. Why suddenly everybody moved to the cloud? Well, there are a few problems with on-premise deployment. And the main of them is that we just need to take care of so many things. We need to think about capacity management. We need to ensure that we have the right number of machines. And if we get this number wrong, we will have problems. If we have too few machines, then our customers, then the requests of our customers won't be served, and they won't be able to use our application. And if we have too many machines, then it means that we had to buy them, and then it means that those money could go somewhere else to spend them on something more useful. And then we would have to do hardware management, we'd have to install software, configure it, hardware. We need to maintain it, we need to upgrade it, we need to install newer hardware when we need to. We would also have to care about security, and we may even have to care about security on all levels, including physical security. We had to think about how we can ensure that only right people can access our data centers. We also have to install operation system updates, and this also will be our responsibility. And we would have to think about things like how to properly decommission hardware. Say if we have a hard disk, we would also need to think about how do we shred it so we don't leave any private keys or passwords on it. We would also have to think about networking. How do we connect our devices? How do we provision switches and routers? And how do we connect everything together? And we also need to think about storage. We would need to think where do we store files for our applications, how to configure the system, how to scale it, and so on. So of course, all of this can be done, and it was done by different companies. But here is the catch. Why don't we do this anymore? Why don't we want to do this anymore? The thing is that our users don't care about data centers. They care about how an application works, and for them, data center is not important implementation detail. And as a business, we need to focus on delivering value for our customers. And managing infrastructure requires time, it requires money, and it takes attention away from actually improving the product. And the second problem is that managing infrastructure requires expertise. It should be done correctly. And the idea that drives the development of public clouds is, can we just pay someone else to do this management better and cheaper? And this is not only something that initiated the creation of cloud providers, but it also what is driving evolution of the cloud even today. So now let's talk about infrastructure as a service, which was the first option that became available for users of cloud providers. So the main idea of infrastructure as a service is that servers with infrastructure as a service are treated like a commodity, like electricity. You just consume, with case of electricity, as much as you need. If you need to consume more, you just consume more. If you need to consume less, you just stop consuming. The same idea is with infrastructure as a service. The cloud provider owns servers and manages them, and we can rent a server from a cloud provider, and we can stop renting them at any time, just when we want to. And the second big benefit of using infrastructure as a service is that we can interact with this infrastructure using APIs. So for example, if we want to rent a server, we just need to send an API request to the cloud provider, and we have a server we can work with. And the additional benefit of this is that using this API allows us to implement DevOps practices. And in a nutshell, DevOps allows us to automate infrastructure operations, and it allows us to solve infrastructure problems using software. And in infrastructure as a service, a cloud provider usually provides infrastructure like virtualization, servers, storage, networking, and so on. But it can also provide additional services like monitoring, centralized logging to store login events, alerts to notify us about problems with our applications, databases, queues, and so on. Now, there are a number of cloud providers, and there are a lot of infrastructure as a service options that we can use. The first one was Amazon with its Elastic Compute Cloud, or EC2, but there are also other cloud providers that you can use, such as Google Compute Engine, there's Azure Infrastructure as a Service, DigitalOcean, and then many, many others. Now, just to give you an idea of what it means to use infrastructure as a service, I'll show you how you can use EC2 to provision an instance. To do this, you would have to go to AWS console, go to EC2 service, and click Launch Instance button. And once you click that, you can just provide a configuration of what sort of instance you want to provision, specify the type of an instance, additional parameters, and in a few minutes, you will have an instance, for example, a Linux box that you can work with. And of course, in addition to using Amazon Web Console, you can also send API requests, or you can use a CLI tool. Now, there are a few benefits of using infrastructure as a service. So one of them is that we don't need to buy hardware, we can just rent it. And if we want to rent one more machine, that's one API call away from us. Infrastructure is now managed by a cloud provider, so instead of focusing on configuring our infrastructure, we can focus on something else. We can focus on implementing our applications. The second very important benefit is elasticity. And what this means is that we can, on the spot, increase or reduce the number of servers. And this is especially beneficial because we pay for the service per hour. And if demand for our application increases, then we just provision more service and we would have to pay more. But if demand decreases, then we can provision less servers and then we can just pay less. And all of this creates a lower entry barrier for applications, so it's easier to develop new applications if we use infrastructure as a service. However, if we use infrastructure as a service, it does not solve all our problems. And there are a lot of things that we still need to care about. So first of all, we need to think about how we deploy our software, how we install it on machines that we provision, how we update software on those machines. We would need to care about high availability and scalability. Infrastructure as a service provider only provides tools for that, but we would have to configure them properly. We would have to think about load balancers, auto-scaling, multi-data center deployments, or multi-AZ deployments, as it's called with AWS. We would have to manage operating system. We would have, for example, install updates. We would have to select hardware that we want to use. We need to select what instances we want to have, how much CPU, RAM, and what disk configuration we want to have. And we would have to configure some network parameters, like we have to create VPCs and configure firewalls. Now, there are Now, what are the reasons why we would use on-premise deployment? Why would we use our own hardware instead of using infrastructure as a service? Well, there are a few reasons to do this. Well, first of all, the reason is that when we use infrastructure as a service, we give up some control, right? It may be a good thing because now a cloud provider should handle more things, but we still lose control of what hardware we can use. We lose some control on how we configure our infrastructure. So if we really want to have all configuration options for all the hardware that we can have in our data center, then we would have to go with on-premise deployment and not infrastructure as a service. Well, the second problem is that in the long run, it may be more cost efficient to run your own hardware. And this is a very tricky option and this is a very tricky thing to count because, first of all, you need to include costs, like you need to pay specialists to configure your infrastructure, but also depending on what application you use and how stable the demand for this application is, the calculation of costs can be trickier. And sometimes you cannot use a cloud for legal reasons. For example, some countries demand that user data should reside in a specific country, and in some cases, there are some countries that don't have cloud providers. And the last reason is that some applications may have been developed a long time ago before the creation of the cloud, and to deploy them to the cloud, they may have to be completely rewritten, and this may not worth the investment. The question is, can you implement something like infrastructure as a service yourself? Can you just manage your hardware? And usually, the cloud provider would have more expertise in infrastructure management, and usually cloud provider will provide a better service than an average company can. And the cloud providers also have access to talent pool that most companies don't have. So for example, AWS hired an XCA security chief. Probably this something that an average company won't be able to do. However, there are a lot of companies that have a lot of expertise in infrastructure management that decide not to use cloud. For example, Facebook, they use their own data centers because they have a lot of expertise and because they are huge. So maybe cloud is just not for them. But on the other hand, Netflix runs everything in cloud, and most of their services run in AWS. Now, we've covered what is infrastructure as a service, and with infrastructure as a service, running a single machine is now easy. But what about running an application that should run on multiple machines? And also, what about running an application that consists of microservices? And if you're not familiar with microservices, this is a pattern that allows us to split our application into multiple independent services that communicate with each other. So that would be a bit tricky with infrastructure as a service. We would have to implement a lot of tooling to use infrastructure as a service. So the solution to this problem, as for now, is what is known as containers as a service. And before we talk about containers as a service, we need to talk about two technologies that work together that make this possible. And the first one is containers. And containers, when we want to use containers, we have to package our application with its dependencies into what's known as container images. And then we can execute those container images. And when they are executed, this is called container. Now, containers work similarly to virtual machines. So they, when they run, they can reproduce an environment precisely for a particular application. We can run them on different machines, and they are isolated from each other. So it sort of works as an isolated sandbox for an application with all its dependencies. But containers are much more lightweight than virtual machines. And we also can share them. We can store them in registries where we can download them from. And the main implementation of images is developed by Docker. And Docker is a set of tools that allows us to work with images and containers. Now, the second solution that I will talk about that is important to understand is called containers orchestration. Now, if we define our application, if we compose our application from containers, then we can use a container orchestration tool that will manage infrastructure and run containers and run our application in containers. And the main tool for container orchestration is Kubernetes. There are also other tools, but by amount of users and by amount of application, this is the clear winner in this area. And we will talk about those two options in more details, and we will talk about how is this related to cloud providers. So first, let's talk about Kubernetes. So Kubernetes is a project that was developed by Google in 2014, and it's based on its internal service called Borg. Google wasn't able to open source Borg itself because it's too tightly coupled to its internal infrastructure. So Google decided to re-implement it, and the Kubernetes is a project that Google created. It is an open source project. It is written in Go, and it is not owned by Google anymore. It is now owned by a nonprofit organization called Cloud Native Computing Foundation. And Google now is not the only contributor to this project. There are over 20,000 contributors to Kubernetes, including companies like Red Hat, Microsoft, VMware, and so on. Now, Kubernetes is by far the most popular container orchestration platform, and you can run applications with Kubernetes anywhere. You can run them on-premise, you can run them on your development machines, and you can use one of the managed servers that allows us to run applications in the cloud using Kubernetes. And this will allow us to simplify deployment, configuration, and maintenance of our applications, and you will see how that works in just a minute. And the main benefit of using Kubernetes is that when we use it, we can now think about our application in a whole, about the components it consists of, and not think about individual machines where we want to deploy different components of our application. Now, Kubernetes has a complex configuration, but here is a simple example that we could use. So in this case, we create a Kubernetes deployment. We say that we want to run a container. In this case, this is Nginx container, which is a popular web server. We specify that we want to run 2 replicas of this container. And if we pass this configuration to Kubernetes, it will create 2 instances of this web server. And as you can see here, we don't specify what machines to run it, what IP addresses to provide. All of this will be handled by Kubernetes. The way this works is that if we run Kubernetes, Kubernetes has a number of worker instances that it can use. And if we send a request to Kubernetes that it should deploy our application, it will run instances of images, it will run containers on those worker nodes to deploy our application. So a thing to keep in mind here is that we don't specify how to deploy them on each machine. We don't specify what changes to perform. All we do, we specify the end state that we want to achieve, and Kubernetes will decide how to transition from current state to the end state. We can run Kubernetes ourselves, but multiple cloud providers provide different container as a service solutions. Well, one of them, I would say Amazon Elastic Container Service. This is not Kubernetes. This is a proprietary solution from Amazon that was implemented before Kubernetes. But Amazon also provides Amazon EKS, which is a managed Kubernetes service. And there are also other implementations from other cloud providers, such as Google Kubernetes Engine. There is Azure Kubernetes Service from Microsoft. There's IBM, also has its own Kubernetes service, and there are many other providers as well. Now, so the main benefit of using Kubernetes, the main benefit of using container as a service, as I said, is what is known as a declarative deployment. We don't need to write any scripts, so we don't need to call APIs to specify that on this machine we want to run this particular instance of this service. All we do is we define the final state of our infrastructure, and Kubernetes migrates our application to a desired state. Now, Kubernetes also have a rich ecosystem of tools that allows us to enhance our applications. And another important benefit, which becomes more and more popular nowadays, is that it allows to avoid vendor lock-in, because there are different providers that allows you to run Kubernetes. And all we need to do is to provide a configuration to run our application. We can easily migrate from one cloud provider to the other if you want to. And another benefit of using containers specifically is that if we use containers, we can now pack multiple small services on a single machine. Just because containers are which consume much less resources than virtual machines, you can just run multiple containers on a single machine. Now, we can deploy Kubernetes ourselves. There are a few components that we need to install and configure. It can be quite complicated and cumbersome, or we can just use a managed Kubernetes from the cloud providers that I mentioned before. And they will provision Kubernetes cluster for us. They will manage and upgrade this cluster to install newer versions, and they will implement best practices for us. And then all we need to do is to just deploy our application, to specify configuration for our application and deploy it using Kubernetes. And if we use the managed Kubernetes, this is the same as using our own custom Kubernetes cluster. So we would have to use the same set of tools that we would use if we were using on-premise deployment. Now when we've covered containers as a service, we can talk about another more high-level option, which is called platform as a service. So platform as a service is an option where cloud provider manages even more infrastructure. So if we use platform as a service, what we need to do is we just need to upload our application to a cloud provider. And depending on what platform as a service we use, and there are many options, we just maybe need to upload a zip file with source code of our application, or we may need to upload a packaged application or a Docker image. And then we need to provide a minimum configuration, say a number of instances that we want to run. And then the rest is done by a cloud provider. Now, platform as a service were developed even before tools like Docker or Kubernetes. And one of them, Google App Engine from Google, was released in 2008. But there are also other platform as a service options, such as Amazon Elastic Beanstalk, Cloud Foundry, Heroku, and many, many others. Now, I'll just show you an example of how to use a specific platform as a service option from AWS called Elastic Beanstalk. So the first thing that we need to decide is it going to be a web server environment, an application that will serve HTTP requests, or it should be a worker environment for long-running processes. And when we make this choice, then we can specify the name of our application, specify a platform. For example, we want to run it on Node.js, and then deploy and then upload our application. And then once it's uploaded, we just can configure it using this sort of dashboard. We can, for example, specify what instances to use. We can specify how many instances we want to run. We can specify if we want to have a load balancer, specify how to update our application, and so on. Now, using platform as a service has pros and cons. Well, the benefits of using platform as a service is that a lot of infrastructure management is now handled by a provider. And it has even lower entry barrier. And I would say it's easier to deploy than using Kubernetes. But the downside of using platform as a service is that it is opinionated. Cloud provider decides how you can run applications using platform as a service, and it can limit what applications we can deploy. And it can limit what languages or environments we can use to run our applications. So now we'll get to the last topic of this webinar, which is called function as a service. But before we talk about function as a service, we will talk about something very related called serverless. And serverless, I would say this is not a technical term. It's probably like a trend in services that are developed by cloud providers. But those services, those solutions have common characteristics. And they include that when we use a serverless service, then we don't pay for idle resources. We pay per request. We don't pay if our service that we provide is not used. We don't do any infrastructure management at all. And auto-scaling and high availability are enabled out of the box for serverless options. And there are multiple serverless services. They can be databases, queues, data analytics services, orchestration, and so on. But the compute in the serverless world is implemented using function as a service. And to use function as a service, so we now need to split our application into small functions. And then we need to upload those functions to a cloud provider, and the rest is implemented by a cloud provider. Those functions are event-driven, meaning that they are called when an event of a particular type occurs in the cloud environment. And then when we use function as a service, we would pay per invocation. If our functions are not invoked, then we don't pay. And cloud provider takes care of the rest. It takes care of provisioning servers. It takes care of scaling them up and down, and we don't even have a view of what service this application runs on. We don't have control of what service to use and so on. Reliability, auto-scaling, that would be implemented by function as a service. And managing servers, installing updates, we don't even have visibility into how this is done. Now, here is how that works. So to use a function as a service option, we would first have to upload our function to cloud platform, create a function, and then we would have to define an event source and specify when our function should be called. Now, when this event source generates an event, and we will talk about what sort of events we can have in this sort of model, this event is being passed to our function, and the function can execute its logic. When it processes this event, it can use external resources such as databases, it can call other services, and so on. Now, there are many options for function as a service. The first one was AWS Lambda, which is the most popular function as a service option as for today. But other cloud providers also have implemented similar services such as Google Cloud Functions from Google, Azure Functions from Microsoft, IBM Cloud Functions from IBM, and there are also a lot of other providers. And you can also use, well, what is known as on-premise serverless options. So you can run your own data center, but have a serverless-like experience when you deploy your applications. So here is an example of a simple function using AWS Lambda. And in this case, the main parameter that we use in this function is event that we need to process. Then we can get, an event is just an object, just a JSON object in this case. We can read fields from this event. We can implement the logic for our application. Here we just increment the number field and then return the result to a caller of this function. And now a very interesting question is, what sort of events can our function process? And for example, in case of AWS, we can process dozens of different events. An event can be an HTTP request. So when a user sends an HTTP request to our server, then Cloud Platform will convert this to an event and send it to our function. We can also be notified when a file is uploaded to a file storage and react to this using a Lambda function. We can configure our Lambda function to process messages in data streams and queues. And we can configure a Lambda function to process voice commands using services like Alexa, which is a voice recognition service from Amazon. Now, our function can use a lot of different resources. This is just the code, and it can interact with databases. It can call other functions. It can send emails. It can use other services, for example, like image recognition, and it can use HTTP APIs. Now, where it becomes really interesting is how much does it cost to use something like AWS Lambda or other function as a service options. And in case of AWS Lambda, every month you get a free tier, which allows you to send 1 million requests to your function per month for free. And it also gives you 400,000 gigabytes per second of compute time, which means that if we provision our function with 1 gigabyte of memory, we can run 400,000 seconds of functions that use 1 gigabyte of memory. And then after this, once we covered the free tier, we would have to pay 20 cents per million requests, or this amount of dollars per 1 gigabyte second of compute. And of course, if we use AWS Lambda with other AWS services or any other function as a service with other cloud services, we have to pay for those services as well, and we have to pay for sending data out of data centers if we use AWS. Now, the question is how to deploy AWS Lambda applications or function as a service applications. Well, we just need to upload code to a cloud provider and we'll take care of the rest. To do this, we can use CLI, we can use APIs, or we can use Web Console. But a better option is to use a framework that was created for this purpose. And the most popular option as for today is known as the Serverless framework, and this is the name of a framework itself. What it can do, it can compile and package code for us. It can then upload this code and create our application in AWS, or it can also support other cloud providers. And then it allows us to build complex applications, and it allows us to create additional resources so our application can have dozens of functions, and it can use services like databases, file storage, and so on. And it's a very customizable solution. It has a lot of plugins that we can add to enhance functionality of this framework. Now let's talk about pros and cons of using function as a service. Well, the main pros, the main benefit is that it is easy to develop an application using function as a service. Scalability, reliability is taken care of for us. We don't even need to configure anything. Just deploy a function and the cloud provider will take care of the rest. And it has quite low cost, especially if our application is not used, then we just don't pay for it at all. And all of this allows us to focus on a business value for our application. It allows us to focus on business logic instead of thinking about how we need to configure infrastructure and how many machines do we need to provision and so on. However, I would say that using functions as a service is not for heavy workloads. It will be cheaper to rent an EC2 instance. So for example, if you have a high CPU load and you need to crunch a lot of data, then provisioning an instance would be cheaper, but only in case if it's processing data all the time. The second is functions as a service platforms have specific limitations. So for example, AWS only allows to provision up to 3 gigabytes of memory per function, or it only allows to have at most 2 CPUs when a function is invoked, and so on. And different platforms will have different limitations, but those limitations are much stricter than if you use EC2 instances. The third thing that people are worried about is vendor locking. So if you use platform as a service, then you need to define your functions in a specific way. The events generated by a cloud provider have specific structure, and different cloud providers will have different structures for the same events. So it may be harder to move your application from one cloud provider to another if your application uses function as a service. However, the good news is that CNCF, the same organization that owns Kubernetes at the moment, is now developing standard for serverless events. And then the last point is that to use function as a service efficiently, we may need to rewrite our application, and maybe even we have to use different patterns when we want to develop our application. Okay, so we went through different options in this webinar, from the most oldest options or most low-level options to most recent options to deploy and develop our applications. And we started with on-premise, which is an option when we don't use cloud services and run infrastructure ourselves. Then we talked about infrastructure as a service that allows us to rent machines from a cloud provider. Then we talked about container as a service that allows us to run our application in multiple containers. Then we talked about platform as a service that, and in the case of platform as a service provider, cloud provider manages most of the infrastructure and abstracts us from details of infrastructure management. And then we talked about function as a service, and this is usually used in the context of serverless, and it abstracts us from managing infrastructure completely and allows us to focus on business logic of our application. Now, the more we go down this list, then the more high level of abstraction we use. So if we use on-premise, then we have to take care of everything. If we use function as a service, then we just need to focus on our code. However, I would say that the lower you go on this list, the less control you have over your infrastructure. Of course, when you use on-premise, you can select what hardware you use, you can select how to configure it, while if we use function as a service, then we don't have any control over hardware that we use, any control over infrastructure. Well, and I would say that none of the solutions is a silver bullet, none of them is a perfect fit for everything. And as we've discussed, each one of them have pros and cons. And the good rule of thumb, if you need to select between those solutions, can be that it makes sense to select the most high-level option for specific use case that you have. And of course, you can have other concerns, but this can be a good starting point when you need to make your decision. All right, so thank you very much for your attention. This is all I have for today. And do you have any questions?
Ivan, thank you so much for walking us through all this. This was a great presentation, and I certainly learned a lot about how, where to use what kind of services and what level of abstraction. So maybe like one question that I have for you is, and let's role play a bit and see from your experience which one of these services or a platform would you recommend, right? Okay. So let's say I am a one-person army. I have a brilliant idea that I want to, and I want to start my own thing, but I don't know where to start. At that time of the process, which service or which, where should I start?
So if you one-person army and you have a brilliant idea, I would probably suggest to use either platform as a service or function as a service, because in this case, you don't need to manage your infrastructure. Maybe if you just want to deploy a web application, then you can go with platform as a service. If it, however, it needs to be something more complex, when you need to process events from your application, maybe if you don't want to pay anything for infrastructure, if your application is not used, I would go for function as a service. But I would say function service would probably provide more flexibility in this case.
That's great. So now let's extend that a bit more. So I did a couple of prototyping. It seems like I was able to launch a product and I was able to see some traction. So I decided to hire a few more developers to work with me on my idea. And now we are a developer team of 10 to 15 engineers. We are still iterating, but we have like some direction in which we're going. Does that change whether I should be using platform as a service or function as a service?
Well, it probably depends on how people are familiar with function as a service and the nature of this application. So I would say it depends, right? But when its application becomes more complex, then you can either go with container as a service even, but that requires already some expertise with containers and Kubernetes and some engineering practices if you want to go with this approach. And it will also require more infrastructure management. But you can also go with function as a service, and there are a number of successful startups that went 100% with serverless solutions and function as a service. So all their code is running in functions, and that worked for them.
Great. And the last scenario here is like I'm a super big enterprise, like I'm working as a cloud engineer in a super big enterprise, and I have some of my existing applications which are just lying around in my own on-premise, and I have to move them to cloud. How should I think about moving my on-premise applications to cloud?
Well, that probably depends on application, but I would imagine if it's an old application, it would be easier either to move it to infrastructure as a service that probably will have the lowest entry barrier for old applications. It would be harder to move them to container as a service, but it's still a viable option, especially for big enterprises. One other concern can be vendor locking, and using container as a service and services like Kubernetes will minimize this risk, will allow them to later change their mind and maybe migrate to other cloud provider. And yeah.
Great. So we have some questions from the students as well. So this question is from Patrick. So he says he's learning data science here, and from his understanding, there are a couple of use cases for data scientists for using cloud services. Can you give like some of the practical use cases for data scientists for cloud?
For data scientists, I'm not that familiar with data science toolkits, but I would say that it either can be, you can actually use managed services from different cloud providers to do data analytics. You can use serverless options to do data analytics. You can even go with, say, function as a service if you want to, but I must say I'm not that familiar with data science. If you want to, say, process a stream of data, then you can use function as a service, but I'll probably go with some managed services if they're available.
Great. Another question from Ricardo. Can I use PHP with Lambda?
Can you use PHP with Lambda? So with AWS Lambda, you have the limited number, well, not limited, but restricted option of what environments are supported by AWS. And up until the last reInvent, up until 2018, you can use only what AWS provided by then, which was Node.js, Java, .NET, Ruby, Go, and Python. But since the last reInvent, you can implement your own environment to run in AWS Lambda, and you can upload this environment. And as far as I remember, there is a project that allows to run PHP as well in Lambda. And well, now it's easier. You could do that before. You could just upload PHP executable and use it in Lambda, but now it's much easier. There's also a project that allows to use Cobol in AWS Lambda. So yeah, there are more options as for now.
Well, that's great. That's good to know. So I think that brings us to the end of all the questions that we had from our students today. So it doesn't seem like we have more questions, so I will let you go, Ivan. Thank you so much for taking your time to go through this presentation. For all the people who are attended today, thank you so much for joining the call. As you know that we have just launched our 2 Nanodegree programs. Do check them out on our Udacity websites. Both of them are, if you have any further questions, do write to us. And we will be sending out the recordings for this presentation at the end of this webinar as well. So thank you so much all for your time today. Have a great rest of your day.